All right, hello and welcome. Thank you for being here today. This is our final Flow Ecology Special Study SAG and TAG webinar. I'm going to jump into the webinar procedures before we kind of get into the presentation, just so everyone's a little bit familiar with this virtual format. So if you have any questions or comments, you can do this throughout the presentation. We do have Q&A slides that will come up, but you don't have to wait for those. You can do it throughout. There's a little chat bubble that kind of looks like a little cartoon chat bubble on your screen that you can choose and type out your question. And if it's a long question, you don't want to type it out, you can just say long question and we'll unmute you when the Q&A slides come in. And then also there's a hand raise option if you can't find the chat option or something, or you just want to be able to speak your mind once the Q&A slides come up, you can use that as well. So that's this little person with a little high five up in the air. They're raising their hand and we'll unmute you during the next Q&A. If you are joining via phone, you might need to press *6 to unmute yourself. And then if there is like a lot of background noise and people aren't, like attendees aren't muted, we might mute you during the presentation. But then we can unmute you if you raise your hand or chat us during the Q&A slides. Another thing is that if you are on the browser version of Teams, what you can do if you don't see this little bar that has these options on it is you can kind of click out of your screen and then click back in, and it should show up again. Sometimes it disappears. We've found that happens to some people. And if you're having any issues, you can email me or you can email Cindy Rivers, and we can try and help you out during the meeting. One last thing is we are trying this PowerPoint Live option where I've actually shared the PowerPoint slides here with you so that you can move forward and back throughout the presentation while we're talking. It might get a little bit confusing if you're on a slide that we're not on, but just in case you want to go back really quick or want to maybe go forward, you can kind of look through the presentation as you go. And there should be, if you're not on the same slide as the presenter, there should be a button that says like live, go back to presenter slide, or it'll tell you like a number. So if you were to do it right now and you were to move around, you would see like a 3 that says that the presenter is on slide 3, and you can easily go back to whatever slide we're referencing. And so that's kind of what's nice about that, but also one of the main reasons we did that this time was because any links that you see on the screen, you'll be able to click. They're clickable links. I can also add them to the chat as well if you want to access them that way, but I think that it's pretty nifty that you can click on any links that we're sharing here. So I'm going to stop because that was a lot of webinar procedures. If anybody has any questions, you can raise your hand, you can chat us. I'm going to give a few minutes to hear back from people. And yes, we did share draft slides, and I've uploaded the final slides in that same location. So I can share that as well. I'm not sure which link that one is, but it looks like it's probably the same as this, that has the agenda and it has these final slides posted
Correct.
there.
Yeah, awesome. That's the same one. So either one of those links we sent will work.
Thank you, Erin. Okay, I'm not seeing any other questions, so I'm going to jump in. Thank you again all for being here. We're looking forward to going over our study, and I'm going to start off with the Wqip background. So the South Orange County Watershed Management Area has a Water Quality Improvement Plan, or a WQIP, and it identifies 3 highest priority water quality conditions and details strategies or schedules for addressing those conditions. So it does identify unnatural water balance as a key stressor for biological integrity. And the WQIP relies on a function-based framework for stream restoration, which recognizes that efforts to improve riparian biological communities are likely to be most successful if the supporting foundational layers are in place. So while our stormwater program has aspects of this entire hierarchy with mitigation and illicit discharge detection and elimination and general municipal housekeeping and so on. We also want to be sure to include flow management strategies that address hydrology and water balance issues. So this slide kind of goes over the objectives of the flow ecology study. If you've been with us at past meetings, you've probably seen this before, but I do want to welcome anybody who's this is the first meeting for them. There's a lot of information that we've gone through, and this kind of gives you the objective of today's or the study. So we want to develop tools and data sets to inform decisions regarding those flow management activities I was talking about, the bottom of that triangle, or pyramid, I should say. We want to align our MS4 actions to be supportive of overall rehabilitation and management efforts. We want to support the design and permitting of future projects, and we want to support prioritization of projects for funding. We really had a strong emphasis on incorporating input from a stakeholder advisory group and a technical advisory group throughout this whole process. And so this slide kind of goes over all of those past meetings that we've had. There was an online webinar to kick us off in 2019, and then since then we've had a lot of in-person and virtual meetings about various topics for this study. And what's great is because of that, we really appreciate everybody's participation and discussion and questions and suggestions, because through all of those meetings, we've been able to agree upon the overall flow ecology multi-level process, which you'll see today. Chris and Katie will be going over it. And then we agreed upon the study area domain and discussed priorities for calibration improvement with the LSPC model. Again, we'll be going over that today. Aaron will be going over that. We discussed the prioritization approach with level 1 and 2, and then we also selected focal species through these SAG and TAG processes that were of management concern and gained input regarding species model development, which is the level 3 of that multi-level process. So now we're going to our first poll. We kind of wanted to gather some information about all the attendees today. We want to see, you know, is this your first workshop, or have you participated in others? So go ahead and try and click on the link on the screen, but I'll also add it to the chat box. And once you're there, you should be able to input your name and the organization or agency you're with, and then click on which workshops you participated in. This is great. I'm getting a lot of great responses. We've had 7 responses, 8 responses so far. It looks like a lot of people joined in maybe the latter half of the workshops, which is great. This is awesome. All right. I'm going to give a few more minutes for responses, and then I can share the results in the chat. I do recognize a lot of your names in the attendee list, so I'm not too surprised, but it is nice to know that we have some people on the SAG and TAG that have been with us since the beginning. So let me go ahead and screen grab the ones that are there so far. I will add it to the chat. And so you can see a lot of, out of the 15 responses, a lot of people have been to the hydrologic model calibration, the 2 purple and pink ones, and the recalibration. That was 11 people that have been to those. So a lot of repeat attendees, which is great. So If this is your first time, or maybe you've only been to a handful of meetings and you're still kind of unsure about what the study is about or what we'll be talking about today, don't worry too much about it because we're going to be going over the study in its entirety. So yeah, let's move on to kind of what we were asking when we started this study. So in the Wqip, we committed to studying these key questions 1 through 7. And basically, we wanted to know the reference condition of streams, how they relate to ecological benchmarks, how to fill data gaps, and the alteration status of the biology and hydrology of our streams. So that's questions number 4 through 7. So once we knew if hydrology and or biology was altered, we could prioritize reaches for protection, monitoring, flow management, and separate stressor evaluations. Okay, so as a general outline for the study, we coordinated with stakeholders, which is what we've been doing with these SAG and TAG meetings. We assessed hydrology and ecology in order to develop flow ranges that support various biological end goals. And that's data that we could then use to evaluate future BMPs. So remember back to the Wqip key questions, we're looking at all of these in order to answer those. It will be one piece of a larger project planning puzzle where we are going to be using the data here to help inform some of the prioritization processes to come. So with that, I'm going to go over to the goals for today, and then we'll get into an outline. So the goal is to present the study results and the final data products, and to discuss potential application of the tools. We'd love to hear from you all. The outline, there's going to be the hydrology review, which Aaron Presky with Geosyntech will be going over. And then with the results, we have Chris and Katie Chris Taniguchi-Kwan and Katie, I'm blanking on your last name, Katie, I apologize.
Irving. Katie Irving.
Thank you. So they will be going over the flow ecology analysis level 1 and 2. We'll have a short break before coming back to level 3 and some of the climate resiliency study that we did. We'll end with some overarching conclusions and potential applications of the study. And so with that, I'm going to go to the next slide, and Aaron is going to take control of the slides from here, and we will move forward.
Great. I assume it's still showing up well to you, Amanda. It looks different to me.
Yes.
Excellent. So yeah, this will be a brief tour through the hydrology work, intending to catch everybody up on the major efforts in this regard and the major findings, but certainly not exclusive. I think our magnum opus on hydrology was really last November when we presented the recalibration and presented a lot of additional information about that calibration. So if anybody's interested in a deeper dive into the calibration, I'd certainly recommend getting back to those November 2020 slide deck. You can take a deeper dive, but certainly happy to answer questions as they come up here. So the hydrologic modeling was done in LSPC, which is a derivative of HSPF, which is a derivative of the Stanford hydrology model. It's been around for a really long time. There's a good body of knowledge as to how to set this up and calibrate it. It's got a lot of functionality for modeling the types of watersheds that we're focused on. Specifically, the processes that we're trying to model are those that are sort of characteristic of these urban, suburban watersheds. We have runoff from the land surface. Some of that, I should say, we have precipitation and evapotranspiration demand applied to the land surface. That results in some runoff, that results in some seepage. Some of that seepage can come out via shallow pathways or interflow. Some of it goes to a deeper layers of groundwater that emerges more slowly and over a longer period of time. That's sort of the loading process, and then the model includes stream segments, and so these stream segments receive both that runoff flow as well as the base flow from the watersheds. And in these systems, there are both diversion type of losses, where there's actually water being diverted from the stream. There are evapotranspiration losses from stream vegetation. There could be infiltration losses. There could be some other types of losses as water flows through the channel. There can also be gains, as water from the land surface contributes to a gaining reach in the channel. But we route this through each segment of the watershed. The watershed divided into about 70 segments. And we're tracking the flow at an hourly resolution for a period of about 30 years to be able to characterize a long-term representative flow regime across different climatic patterns, and including the long-term droughts and including the heavy rainfall that occurs, in individual storms and accumulates over the course of a winter. So this is a relatively right-sized hydrologic model for the scale of this study, in the sense of being able to provide realistic estimates of flow in these riparian systems, at the scale of these subbasins. And I'll show the subbasins on the next slide. So we modeled the current condition, which is trying to represent the current water use patterns, the current controls as they exist today, the current land uses as they exist today. That's the one that we calibrated. We then started from this base model and established two hypothetical scenarios. One is a reference condition. We're removing all of that urban land, removing the irrigated agriculture, removing diversions and impoundments, effectively removing the primary effects of urbanization from the model. And then modeling the exact same time period. So we'd have a comparison, a one-to-one comparison between, what this system looks like for a given series of climatic periods in a reference condition versus a current condition. And then we did the same for water conservation, stuck with the same time period, but pulled back on water, on outdoor water usage, in line with what we've gained from partner water districts as to what their plans are and what their projections are related to reduction in outdoor water usage. That was also done for that same time period. So we have these three stacked scenarios all looked in at the same time period. So there's no difference in the hydrology inputs to this, only difference in what the landscape looks like. And then, of course, the associated flow patterns. And then the one scenario that does have a different time period is the climate scenario, because these are records that are projected out into the future. And so for this, we looked at a kind of a base scenario, which is about 1980 through 2005. And I might have got those dates a little bit wrong. And then we looked at a future scenario, which is a similar time period that brackets 2045 as its kind of midpoint. And so looking out as to, now we have the same type of model. It's definitely a different model. Climate models are all more averaged there, but now we have a one-to-one comparison between baseline and future to kind of get a sense of how things may change. So that's how we used the hydrologic model to support this study. So this is the model domain, and you'll see that the light blue hollow outlines are the primary focus area of the study. These indicate the degree to which the watershed was broken up from a subbasin standpoint. Within each one of these subbasins, of course, there's a whole array of different land use types that are each generating runoff in different proportions. So the actual model is parameterized down to much finer scales, but in terms of where we're actually accumulating all the flow and producing flow results, that's the boundaries of these light blue lines. So it produces, in the range of about 12 increments along Aliso Creek, for example, where we have flow estimates coming out of the model. So reasonably good resolution as to how the flow regime changes through, like, from the top to the bottom of Aliso Creek. The greener areas that are under existing flow management agreements, and again, the purpose of this study is really to focus on areas where there are actions being considered by permittees that need support to inform those actions. And so where there are systems that are already well studied and have agreements in place, the purpose of this, we didn't overlap with that. And then the minor coastal streams, were they primarily through tiny reaches of stream, or directly to coastal outfalls. Those were not the subject of this study directly. So I'm going to go and talk about the existing condition now and how we took that existing condition model and calibrated it. We have really strong hourly stream flow records at Aliso Creek and Lower Trabuco Creek. And so those were one of the primary bases for comparison. We wanted to try and capture the peaks and the things down to the sub-daily level in terms of how these watersheds are responding to rainfall. And then, of course, it's not as interesting during the summer because they don't vary as much by from day to day. But this hourly resolution allows us to look at the hydrograph across seasons and conditions. Those are the two gauges that are strongest in terms of their rating tables being maintained over time. And again, these are water levels being measured and then converted to flow. And so having a reliable rating table is really critical to be able to calibrate a model. But there are several other locations where there are reliable data specifically for dry weather where rating tables can be a little challenging. And so the county's out there monitoring these 6 stations monthly, weighting the stream, measuring the velocity, measuring the cross-sectional area. So getting a really reliable estimate of stream discharge. And something that's ground truthed, it's not subject to sedimentation and rating tables changing over time. So these become really valuable data for us to look at, these dry weather flows, which are among the most important ecologically. We were also able to track down data on dry weather flows from other areas and, in other data sets. And for example, Santa Margarita Water District was able to provide some operational records for Horno and Gobernadora basins, which helped to inform what the estimates of dry weather flow from those upstream watersheds are. And then the final piece of information that we identified in the midst of the study that became really valuable was a series of isotope samples that were taken in 2020. They were taken between March and July of 2020 at 3 different increments of time at about 15 locations across the watershed. I think actually that number might be a little low. And so that really provided a good estimate of how much of that water in each of these streams has an isotopic signature that aligns better with water that fell in the Sierra Nevada, imported water, and how much of it has an isotopic signature that aligns with locally local rainfall and local groundwater. And so those isotopic signatures are rather different. And so the circumstance of imported water in the watershed definitely allows isotopes to be a useful tool for us to estimate the flow, the source of flow. And so just going to share a couple of screenshots of the calibration. And this is a logarithmic scale. That's the only real way to see the degree of alignment across 3 orders of magnitude, between our base flows, in the 1 to 3 CFS and the peak flows above 1,000 CFS. And so obviously there's error in every model. There's certain storms that don't hit the watershed exactly at the same time, as what they were recorded at the gauge. There are, certain processes we're not capturing completely, but we feel pretty good about the level of residual error in this model being rather minor and fairly evenly distributed and indicating relatively limited bias. I will say that low flows are really challenging to model. There's a threshold that goes on at very low flows where it's unclear in any given segment whether water is flowing subsurface or on the surface. Certainly there's a threshold of riparian demand versus the available water that can cause at any one time that flow to be different than what you modeled. And we really start to get down to the level of model precision when we get into the 1 to half CFS. In Trabuco Creek, particularly, there's both a subsurface and a surface pathway, and the gauge data we have is really only for the surface pathway. And so we trust the results more when they get into a level where it couldn't possibly be conveyed underground, but below about 3 CFS, it's pretty, the model is producing a total estimate of discharge through the system, and the gauge is measuring only the surface portion of that. And so we have a bit of an indeterminate situation below about 3 CFS there, where we don't know how much water is flowing on the surface of the system. Here's another example of a calibration in a LISO. This is focused on a whole different part of the flow range. It's focused on the base flows and how that, the storm flows obviously go way off the plot. They look like narrow dashed lines because we're looking at 4 years right here. But it's focused in on, how do we capture that spring recession, that spring recession of base flow and into the summer, and then it's increased back into the fall. So this really helps us understand if we have a reasonable approximation of the groundwater dynamics that exist, and that delayed discharge that sustains flow over the summer, as well as surface runoff, I should say, during the summer from irrigation overspray. And so this is this is another way of looking at the calibration, and feeling good about the seasonal patterns that we were able to capture with the model. I think this is my last slide before a conclusion slide, but this is, I think, important enough from this study to focus on in some ways. And this is the actual results from the isotope, the water isotope sampling that was done in March and July of 2020. And it gives a sense of how this, how things shift from spring to summer, and just the kind of relative magnitudes that we're seeing in different systems. And one of the kind of key takeaways from this is that while imported water is not unimportant, it can be more than half in some systems during the middle of summer. It's not as dominant and primary as maybe was originally thought before this this study, and thought by some, certainly thought by us based on the measurements we'd taken that there might be a greater contribution of runoff, irrigation runoff to the systems. But I think what we learned through this study is that tends to be a more minor fraction, indicating that there are there are considerable rainfall, groundwater recharge, groundwater discharge pathways that exist in each of these systems. So last slide, and then I'll loop back to a couple questions that have come in. But the kind of the key recap before you hear about how this is being used is it's a single model that encompasses the study area. So what we see in terms of baseline, reference, and future, it's all done in the same model. So that creates a level of consistency. So even if the model's not right, which no model is, we have greater confidence in the relative comparisons between the different scenarios. So there's as you saw in the plots, and you could see in other plots that are presented in our progress report and in the slides from last year, there's a strong calibration across a lot of different metrics across seasons and flow conditions, with the limitation that low flows are very hard to model, and we have less certainty in the very lowest of flows. There's sort of a threshold where you can't tell definitively whether that reaches dry or whether it has a trickle of flow in it. And that's, especially when we're away from our gauges where we have actual observations, that can be a hard thing to completely nail down. And then I mentioned the key finding on isotopic data about the role of imported water. We also saw through a previous 2019 study of about 20 outfalls that there was about 50% imported water in those outfalls on average. An outfall in this case, thank you, Carol, for the timely comment. I'll clarify that an outfall is an MS4 outfall. This is a place where the MS4 storm drain system discharges to a creek. And those contain not just irrigation runoff during dry weather. They pick up seeps that come out of hillsides. They maybe water seeps into the pipes itself. But one way or another, these vary widely. Some are 90% imported water signature. Some are 90% groundwater signature. It's pretty widely variable, but on average in this watershed, what's coming out of the storm drain pipes is definitely not all imported water, and that's an interesting finding. And it's important for management, as to the types of projects that would be done at an outfall. And finally, based on these these data, we think that the evidence points to perennial conditions having existed in the lower reaches of these streams without the influence of urbanization.
It's very interesting.
Well, thank you. And yeah, so you know, we've obviously seen pavement come in. The pavement has reduced infiltration pathways. There's been compaction of soils associated with development, and yet with those conditions in place, we still see enough groundwater recharge to be supplying the stream with a substantial portion of rainfall-derived groundwater discharge during the summertime. And so, it seems likely that there would be that in a baseline condition without that impervious cover and without that compaction, that there would have been, similar or greater groundwater recharge pathways that could have supplied a perennial system. And that's said with a lot of uncertainty. I mean, we don't have data to necessarily describe what existed before urbanization, but that is that's an insight that we gained from these current data. And then finally, basically this study, the hydrology portion of the study, provides us with insights about the existing condition. It's certainly helpful to support project development by itself, but as part of this study, it's really serving as an input to what Katie and Chris are going to talk about next. So that's, with that, I'll stop and try to respond to some questions.
Wonderful. Thank you, Aaron. We have a few questions that have come in through the chat while you're talking, so we can go over those first. And then while Aaron is responding to those, if you have other questions, go ahead and use that chat function or raise your hand, and we will make our way through them all. So the first one is from Carol Moore. She asks, with the data available over much longer timeframes using sediment deposits as well as tree rings, there is considerable evidence of lengthy droughts as well as megafloods. Can the 30-year model be viewed within the longer timeframes?
I guess the simple answer to that is it could be, and we haven't. Just to be perfectly transparent, we have used the reference condition as a touch point to be able to evaluate how we think current conditions may be different than that, as one explanatory variable for prioritizing reaches for consideration. But it isn't a goal, and we haven't attempted to try and characterize a certain point in time like 1491 or some certain point. And so I do think that there is probably a historical ecohydrology study that could exist that would go back, and we didn't get there, with this study, partly because of the effort it would have required, and partly because it's not as directly tangible to the results. Most of this is about how do we move forward, what do we think is coming in terms of stream flow regime, and what stream flow conditions are necessary to support the focal species we want to try and improve conditions for in the watersheds. And so, yeah, that's it's a great question, and I think there is a lot of potential fruit that could be born from that, but it wasn't something that we looked at in detail.
Thank you, Aaron. So Dwight has a question on slides 15, 20, and 21. So we can head back over to those slides. And then Dwight, if you have a mic, feel free to unmute yourself.
Yes, I have done that.
Perfect.
Hi, Dwight.
Hi. Yeah, on slide 15, it's kind of a general comment, and it's kind of related to something you just mentioned about how the data that you're analyzing and the scenarios for the conditions are really directed towards future flows and what might be done for management. So looking at the slide on the right side, there are two things. The current condition, you do some evaluation of the current condition based on about 30 years of data that you mentioned, really after 1990. And then you develop reference conditions by removing certain the urban land improvements over those years. and then come up with the reference conditions. And those both, I think, result in eventually a reference flow that you would expect for this future modeling conditions. I think it's important to recognize that reference flow should somehow capture the flows of pre-urbanization, where we do have some data in the 70s. And most of my comments are all related to Aliso Creek at the CTP, so not particularly the other parts of the other drainages. But in the 70s, there were flows of 0.25, 0.5, and 1.0 that were very common in the early 70s to be recorded at the CTP. And there was sporadic measurements that were done, and I'm sure that they were mostly done in response to flood events where they didn't have an automatic station there. So people were sent out when there was a large rainfall or heavy flows. And so, of course, we have many flows in that period which are very high and obviously related to storm events. But there are many that were recorded which are obviously during the very driest periods because they're 0.25, 0.5, and 1.0 measurements are very common. So all I like to say about this particular slide 15 is there's some, it should be recognized that whenever you come up with the reference condition and a reference flow, somehow that flow must reflect and capture or include flows as low as 0.25 because those have been recorded. So that's my comment on slide 15. I don't know if you want to respond to that.
I did have a question about that. I saw your comment come via email yesterday. We weren't aware of those flow rate information. We were aware of an Aliso gauge that was installed below the CTP in the 80s, 82 to 87 by USGS, and then the county established a station at CTP in 2002. But I'd really be interested to look at the data source you have for the flows in the mid 70s and see if we, can.
No, it's I just pulled it off the county website for flow data for Aliso Creek at CTP. So I think you probably are right that it's not, I don't really know, but they were all included in one database, which is the entire span of time for the CTP station. And it includes 1972, 73, 74, 75, 76. And there's sporadic data, but it's part of the data set, the first few entries that you see on the data set. However, if they were all part of a summarized set of data for these lower stations, they're all within 1,000 feet of the CTP, so, or pretty close to it, a couple thousand feet. So I think they reflect the flows in the lower part of the Aliso drainage.
Yeah, if they're there, they would be reflective. Yeah, it was something that we can look into.
Right.
Thanks, Dwight. I literally working with the county's previous data management lead, and I wasn't aware of those previous data sets. So we'll give a look and make sure those weren't mislabeled or whatnot. And if they're valid, I think they're worthwhile to use as a vetting.
Right.
So thank you.
Yeah. So somehow it would verify, or it would be included in the range of flows that might be observed there. The second slide that I have comments on is slide 20, and that's very interesting. I was very, very interested to learn about the isotope monitoring and the results of that. My interest in that particular station down there at CTP is determining what is the amount of water that can be considered urban runoff as opposed to natural runoff. So this data seemed very interesting. It's like a silver bullet to me, because suddenly I don't need all the modeling that you are doing upstream. It seems like this piece of information just quickly tells you that, in this case, 29% of Aliso Creek at the time it was sampled was imported water, which is very interesting. There is a diurnal flow of course, all of these creeks, but at Aliso Creek and at the CTP, there's, for example, in September, I just pulled a random week out in September of this year, and the flows range diurnally from about 2.0 CFS to about 2.9. So very early in the morning, about 8, 9, 10, 11, they flow at the lowest possible level. And then at about 5, 4, 5, 6, 7 in the evening, sometimes 8, 9, 10, they're at the highest. So just thinking about that, the low flows are probably more reflective of groundwater or natural runoff as opposed to the higher flows, which the diurnal system is really generated by people watering their lawns or washing their cars or whatever's happening. And that seems to be indicated by these high flows in the late afternoon. So when I see a number of 29%, my first question is, when was the sample taken? Because if it was taken in the early morning, let's say 8, 9, or 10 o'clock routinely, then that's 29% of, let's say, 2 CFS. If it was taken in the afternoon, when the flows were closer to 3 CFS, then that 29% is 29% of this larger number. So my question is, when were they taken? Or if we can dig up that information, it's very important to know that 29% is a very important number to me. And I would just like to know, was it taken during the lowest flows or some average, or how did that happen?
Yeah, I can respond to that quickly. I mean, it's a good point. These are a certain point in time in terms of the year. I think that's an important thing to notice here, is that they are only 1 year. It came after a wetter winter, and so I think we do need the model, and I think we do need probably more, some additional study of this, for monitoring data to be completely useful on their own right. But I agree with you that this is a good integrator of everything. We looked back. We had the same question. We looked back at the flow ranges on those days, and the days that we actually sampled in say July, the flow ranged from 3.7 to 4.2 CFS during the working hours when the samples were taken. They were taken at various points in time during the day and along Aliso, and so there is potential, some variability, but that's a range of about 15% plus or minus. So I don't think that it's as big of an issue as the range of data suggests. The other line of evidence I have for that is that we have taken sort of more diurnally paced samples of isotopes at outfalls, where we tried to sample the low, we tried to sample the high of the diurnal pattern, and a lot of times those were 2x type of peaking factors, where the high was at more than twice the low. And interestingly, we didn't see twice the imported water in the high as we saw in the low. It was a minor uptick, but not a major one. So there's other things that are driving a diurnal pattern besides the runoff patterns. I think there's probably some level of irrigation. Obviously diurnal irrigation is part of it, but evapotranspiration demand is really important in the system. If you look at the vegetated corridor and the amount of potential demand that could be coming out of the system from riparian vegetation, it's substantial. It's impossible to measure directly, but the sensitivity analysis says that it could be more than 2 to 3 CFS over the course of Aliso Creek in terms of riparian evapotranspiration demand. And so part of this is, probably around that a little bit too. And part of it's the fact that from the upper watershed, it might be a half a day worth of travel time to get from the upper watershed to this gauge, compared to the lower watershed. It might only be 6 hours, et cetera. So there's a lot of sort of, there's various different factors that are driving a diurnal pattern. It's not quite as directly connected between a sprinkler and the stream as I think it's possible to believe. So in other words, I expect it is fairly well mixed by the time it gets to the system, and that had we sampled a low and a high, we wouldn't see a substantial difference. And I say that based on the outfall data, which exhibited even a greater low and high, and we didn't see that much difference at given outfalls. So I I think I realize we're going into a topic that some on the call may not care deeply about. So maybe we should continue some of this, but I really appreciate the comment and the interest in this.
The second comment I have about the isotopes is how much did the isotope information influence your later reference flows that you developed? In other words, was it somehow integrated into the model? Because the model seems to be mostly geographic, of removing certain urbanizing conditions, as opposed to this data, which is different. Did this have any influence on developing the flow values?
Yeah, I'll try for a short answer at this. I could talk about it all day. We calibrated modeling parameters for, if I had to divide it into three main categories, it would be impervious area, irrigated pervious area, and non-irrigated pervious area, although that's now, of course, divided by soil groups and divided by vegetation types and other things that make up a hydrologic response unit. But if I had to distill it down, it's those three major types of land that exist. And we did look at the, we did some deep analysis of the different intermediate fluxes in the model, and we estimated the actual amount of water that was making it past the root zone from irrigation and into the deep groundwater, and then past the root zone from rainfall. We also of course evaluated the amount of runoff from direct overspray onto impervious land, and we looked at how those different components of flow compared to these values that you see on the screen in terms of the imported water, to try and validate that the existing condition model was producing pathways of flow that relatively matched what we're seeing in the isotope data. And so that that led to a parameterization for unirrigated land, irrigated pervious land, and impervious land. And that was our existing condition, and we felt reasonably good about that because of its ability to match the isotopes, as well as its ability to match the seasonal patterns of base flow that we see in the gauge data. And so that did inform the parameterization. Then for the reference condition, we just removed the urban land, we removed the irrigated land, we replaced it with a approximation of what type of pervious non-irrigated land would exist without urbanization, and ran the model again. And so that, yes, so I think the simple answer, which was not so brief, I apologize, is that it is incorporated into the existing calibration of the hydrologic parameters for areas, and then the reference condition just meant removing those urban calibrations and expanding the spatial scope of the non-urban types of calibration parameters that exist in those areas.
Okay, I won't go on with that one. It was a long explanation, but I think I understand. I have one last one on slide 21.
I think we're going to wait until the end of the presentation just to make sure we have enough time for the presentation, but we can circle back after that. I know there's one more question and some comments in the chat, but once we get to the end of the presentation, I'll circle back to those and we can go through them.
Thank you.
Thank you.
Amanda, how do you want me to proceed? Do we want to move on and come back to some of these, or are there still open questions?
Let's move on to the level 1 results. And let's see, I think Chris is going to take control, and then she can forward through the slides.
Yeah, perfect. Can everyone see my slides?
Yes.
Okay, so hi, I'm Chris Taniguchi-Kwan. I'm a scientist at Wqip. I'm going to be presenting with Katie Irving on the flow ecology analysis. And so for this study, we used the hydrology that Aaron described to relate to the ecology to understand where flows are altered and if altered flows are impacting biology. So to do this, we used a tiered flow ecology analysis. I'm going to give you a brief overview of each of these tiers and then show you some example data products and results that we've produced for tier 1. And then I'm going to hand over the presentation to Katie, who will go over tier 2 and 3. So for the first tier, it's all about characterizing hydrologic alteration based on deviation from a modeled reference condition. So how different are current conditions from reference? The key question here for this tier is during what season and in what direction are flows altered? So are flows augmented or depleted? Are they too early or too late compared to reference conditions? And when and where is alteration occurring? So this tier really evaluates the extent of hydrologic alteration across the region. I do want to stress that I think Aaron mentioned this, that we've had a lot of discussion on defining reference. And so I want to reiterate for this analysis in this study, we're using our reference model condition as a touch point, as mainly a point of comparison to our current flows to understand how flows deviate from what we would expect under more natural conditions. Next, we want to know if flows are altered. Is it biologically meaningful in terms of primary producers and consumers? So tier 2 focuses on biologic flow alteration based on bugs and algae using the bioassessment indices, the California Stream Condition Index, CSCI, and the Algal Stream Condition Index, ASCI. So this level is all about identifying high priority reaches for flow management. So it's kind of narrowing in our focus to some of these more priority reaches. And finally, the third tier focuses on biologic flow alteration based on higher trophic level species. So for this study, we're focusing on willow and arroyo chub, representative of more riparian habitat, and then arroyo chub for more aquatic habitat. And so what are the flow and hydraulic needs at priority restoration and management sites, and how might future scenarios affect these species? So these are just two of the questions that we're trying to address in this tier. And so this slide here illustrates how each of the level fits into the overall process. So level 1 and level 2, which is on the left, slide steps 1 through 4, are all about prioritization. So we're assessing hydrologic alteration through tier 1. We're determining if alteration is affecting biology. We're aggregating alteration across years. And then finally, we're synthesizing alteration across different aspects of the annual hydrograph. And so the outcome of level 1 and 2 are priority locations for addressing hydrologic alteration. And then on the right-hand side is the steps of level 3, which is all about identifying flow ranges to inform hydrologic control or restoration. And so we selected species of management concern or interest. We've narrowed down to a select set of reaches of management interest. We identify the most important cross-sectional position, so which part of the channel is most critical for the willow and chub. And then we've identified relevant flow management ranges based on the species models that Katie's going to go into later today. And so with this, it gives you a very broad overview of our flow ecology analysis. So next, I'm going to show you some example data products and results that we've produced under tier 1. And then I'll hand it over to Katie. So let's jump into tier 1, which is all about hydrologic alteration based on deviation from a modeled reference condition. And so for this study, we used a functional flows approach, which focuses on key aspects of the annual hydrograph that have documented relationships with ecologic and geomorphic processes. So we focused in on these 5 key functional flow components that were identified for California streams. So we have our fall pulse flows, which is our first flush, first wetting flows, peak magnitude flows, wet season base flows, the spring recession flows, which transition us from the high flows down to the dry season low flows in the summertime. And so flow metrics allow us to quantify these different flow components. So the table that you see on the right shows all of the functional flow metrics that we have identified for California. And I do want to note that the California Environmental Flows Framework technical team has also created a functional flow calculator found at eflows.ucdavis.edu. So you can check out this link on this slide here. This website allows anyone to upload flow time series and calculate all of these flow metrics on an annual basis. And there's also an R package that was created that's free for everyone to use, where you can batch process calculating these flow metrics at multiple different locations. And so once we had all of our flow metrics calculated for the current and reference model scenarios, the next step is to evaluate hydrologic alteration by comparing the distribution in flow metric values under the reference condition and under the current condition. So what you see here is a box plot of the reference from the 10th and the 90th percentile in red. So these are all of the flow metric values calculated across the period of record. And then on the right, you see the box plot for the range of the current flows that we calculated across the period of record. And so if the current median falls outside of this reference range, then we would classify this as likely altered. Now, if the current median falls within the reference range and at least 50% of the current values fall within the reference range, this would be classified as likely unaltered. And then lastly, if the median falls within the reference range, but less than 50% of the current values fall inside of this range, then this would be a site that would be classified as indeterminate. And so once we classified alteration for every metric in subbasin, we were able to map alteration across the region and for different aspects of the hydrograph. And so we've produced a library of alteration maps that indicate where flows are altered and in what direction. So red means that it's likely altered high compared to reference, orange means it's likely altered low, and blue is likely unaltered. So overall, we found pervasive alteration in the urban areas and across different seasons. So for example, the spring recession rate of change, which is on the left, that's the percent decrease in flow per day from the spring recession. We found that it was altered high, or we tended to have flashier recessions compared to the more reference condition. Especially in the urban areas of Aliso Creek and in some of the more urban drainages. We also found that in relatively undeveloped areas of Upper San Juan and Trabuco Creek that the flows were likely unaltered in blue. And so we found similar patterns for the dry season base flow, which tended to be altered high or augmented in red compared to the reference conditions. Especially in those urban watersheds, and then again, likely unaltered dry season base flows in the more undeveloped subbasins as well. But the next step is to really evaluate if the magnitude of alteration is biologically important, so we can narrow in our focus to some of the high priority subbasins to focus flow management. So with that, I'm going to hand over the presentation to Katie.
Thanks, Chris. Just checking you can see everything, right? Just give me a nod, Chris Colson. Thanks. So I'm going to be talking about Tier 2, which is where we evaluated the flow alteration based on CSCI and ASCII. And throughout this analysis, we also prioritized subbasins for flow management. So that's what I'll be talking about. So basically, in a nutshell, we leveraged extensive regional bioassessment data collected in Southern California to relate hydrologic change to biological effects through regional flow ecology curves. And kind of the first task was to select the most relevant metrics, because we have around about 17 flow metrics available for this analysis. So that was a few too many, because we wanted to reduce it to a handful of usable metrics so we could really focus in on those. So we applied a filtering process. And first we evaluated the relative importance from boosted regression trees, which is what you can actually see in the figure there. The columns are the individual metrics, and the colors relate to the flow components on the side there. So for both CSCI and ASCII, peak flow, which is the green column, was the most important for both, but also spring recession and wet and dry season base flow were also important. So we kept only the most important metrics from this analysis. Then we removed metrics that were highly correlated. Then we made sure that all the remaining metrics had enough data density. So, for example, we didn't want a curve that was driven by a couple of outliers or 1 or 2 points. So we also made sure that the metrics could be influenced through flow management. So through that process, that left us with 3 metrics for each of the indices, and we applied those in a flow ecology analysis. And here's an example of what those flow ecology curves look like. This is taken from CSCI, spring recession duration, which is one of the chosen metrics from the filtering. So spring recession duration is measured in days. So it has the delta H of days on the x-axis, and the delta H is the difference between reference to current conditions. So I'll walk, and it has a probability of achieving a good CSCI score on the y-axis, which is from 0 to 1. So I'll walk you through an example of how we use them. So first of all, we need to have a probability. So for this example, we'll choose the 50%. So anything above 50% will basically be regarded as unaltered, and anything outside of those, well, below that line would be deemed as altered. So it's these points here that are the delta H limits. So for example, if we had a site with a spring recession of 25 days shorter than reference, it would be classed as unaltered, and a site that was 50 days longer would be classed as altered, like here. So we repeated that analysis for every chosen metric to determine the delta H limits and the alteration. So each metric was altered if the delta H, the change of the subbasin, was outside of those limits, and it was unaltered if it was within those limits. Then a subbasin itself was deemed altered if 2 out of the 3 chosen metrics were altered for half of the time. So also subbasins that were likely altered for both CSCI and ASCII were considered a high priority for flow management. So here are the results for each index first from that analysis. So the blue subbasins are the unaltered, and the red is altered. So when comparing the CSCI to ASCII, we can actually see that there are some differences in their alteration. For example, there are some areas in Aliso that are altered for ASCII, but not for CSCI. I'm not sure if you can see my cursor, but it's around about here. But generally, much like the tier 1, we're seeing more alteration in the urban areas as opposed to the undeveloped areas. So then we synthesized across the indices. So here is a high priority basin that I mentioned earlier is where both indices were altered, as in the previous maps. A medium priority is where only one index was altered, and a low priority was where no indices were altered, or they were both unaltered. So this is our final prioritization map, and showing 11 high priority areas, so 11 areas in red. We also have more detailed information on which direction the alteration is. So here, dry and wet season base flow and peak flow are actually too high, where the duration of spring recession is too short. So we actually included this information in the Shiny app, which I'm also going to show the next couple of slides is talking about that and showing you what we can do with that. And so we can recommend flow management focus based on the biological alteration from this analysis. So this is from the Shiny app. I think because you're using the live, I'm not sure, is this, I think it's live, you can try this. So it's a user-friendly application that allows users to easily explore the data products from both Tier 1 and Tier 2, including the alteration and the prioritization maps that we've shown you. And it includes specific data for each sub-basin. So this is an example from Tier 1. You can just hover over the sub-basin, and it shows the current and reference conditions for that particular sub-basin for each of the flow metrics. So that's for wet season base flow. And this is basically what the prioritization map looks like on the Shiny app that I showed a couple of slides ago. So you can identify which flow metrics are altered and may have an impact on biology. So again, you just hover over the sub-basin, and it shows, for example, this one for ASCII. The dry season and wet season base flow magnitude are both altered high. Okay, so using the prioritization from this analysis, from the Tier 2 analysis, we actually categorize sub-basins based on management recommendations. So the biological conditions score in this flow chart is the actual score at each site, and the level 2 alteration is the analysis I've just been through. So if the site has a good index score and is unaltered according to our analysis, we would recommend that that sub-basin was protected. But if it's altered by our analysis, we would recommend to monitor that, to keep an eye on it. If the index score was degraded or unhealthy, but through our evaluation we considered it unaltered, then we would flag that, or recommend to flag that for further evaluation, as there may be some additional stresses that are impacting biology in those cases. And if our analysis shows that site, a degraded site, as altered, then we would recommend flow management in that area. So then, looking at the sites all together, this is what we end up with for doing that. So the most common recommendation would be, in these cases, to evaluate further for separate stresses, and that's for both CSCI and ASCII. We have 32 sub-basins for both indices. That is for further evaluation. But we would also recommend 18 sub-basins for flow management for CSCI, and 22 sub-basins for ASCII. We would recommend flow management, the areas in red. Okay, so I think before we go into Tier 3, I think we can pause for questions here.
Wonderful, thank you, both Katie and Chris. All right, so we have a few questions in the chat. Christine Medic with the U.S. Fish and Wildlife was asking for the difference between ASCII and CSCI, and Eric Stein responded to that. And I'll be posting the chat afterwards in that same meeting materials location that you got. And when you get the recap email for this presentation, you'll see a link to all of that as well. And then we did have a question or a comment from Christine Medic as well. The terminology is misleading. The stream may be altered, but may not impact the indices. Altered should not be used to indicate the less likely impact of altered hydrology. Correction, quote unquote, unaltered should not be used to indicate a lower risk of impact from altered hydrology. And then Eric Stein responded saying, to clarify, we defined quote unquote altered to mean hydrologic deviation from reference that is associated with a change in the biological community beyond a specific threshold, but we are open to suggestions for alternate terminology that would be less confusing. And then Josh Westfall mentioned that it appears at first glance that each of the high priority flow alterations are correlated with flashiness. Is that accurate? Katie or Chris, do you want to respond to Josh's question?
Chris, you might be I'm not
Yeah,
sure.
so yes, can you go back to the metrics? So for sure the peak flow metric is related to flashier peaks. Let me
This
see.
one?
No, to the important metrics for CSCI and ASCII. And then, so I'll say yes for the peak flow metrics. For the spring recession, I think that's the duration. So it's more a matter of a shorter duration in the spring recession. And then for the wet and dry season base flow, Katie, was that for the magnitude?
Yeah, for wet and dry season, it was magnitude. I think for spring recession, it was duration and timing.
Okay, yeah. So I think for the spring and the peak metrics, yeah, those two were typically related to flashier flow regimes, especially in the urban areas.
Wonderful. We have another question that Eric's responded to, but I'll read it out loud. Mike was asking, is the mouth of Aliso Creek at Aliso Beach considered quote unquote altered? And Eric responded, the estuary and the mouth are not included in this analysis. And Eric also wanted to add from earlier, he says, also keep in mind that this is intended to be used as a prioritization tool to identify areas for flow management. So I think I got through the chat.
And, Amanda, this is Eric. I wanted to also add in response to Chris's last response that there's been other analysis done that Katie's been involved with on some of the statewide data sets that has indicated that flashiness and seasonality of flows are also tend to be strongly associated with changes in the biological indices. So that was not part of this analysis, but other work that we've done on other projects.
Yeah, it's a good point, Eric.
Yeah, that's Josh Westfall with LACSD. Okay. I don't see any more comments coming in from the chat bubble. I see one raised hand, but it's Dwight. I think that he might just have his hand raised from earlier. So I think I think we might be good to go to our break. Let me check on the time. So we're about 10 minutes behind. So instead of a 10-minute break, let's do a 5-minute break and we can resume at 10:23. Thank you all for being here. We'll be back at 10:23. right, we've got about 30 seconds left in our break, and then we can continue on with the next portion, which is level 3 study results.
Are we good to go?
Yes, welcome back, everybody. Thank you again for your great presentations, Chris and Katie. And Katie, you're welcome to take it away for the next portion as well.
Thanks. Great. Okay, so the next section I'll be talking about tier 3, which is focused on the biological flow alteration based on higher trophic level species. So in our case, the willow and the arroyo chub. And we asked what are the flow and hydraulic needs at priority locations and how might future scenarios affect these species. I'll be talking about the current conditions, and Chris will be talking about the future scenarios a little bit later on. So after lots of discussion and advice from you all, we chose 3 focal species that we initially looked into. The willow here was the proxy for the Leesbell's vireo. So both that model and the arroyo chub are now completed. However, we tried many times, so several attempts to model the arroyo toad, but it looks like we need more information about that to complete the model. So here's a reminder of the willow model. So all of these models I'm going to show you are built using data from previous published studies. So first, the 2 figures here show seedling mortality response to both depth and shear stress. And with depth here, we just want to point out that even though the species model shows a negative depth, so that's the depth from the surface, we can actually only model 0 depth, so the surface and above, due to the hydraulic model. So with adult, we're basing the model on the assumption that as long as there's some flow in the main channel, the roots of the willow can reach the water. So for the chub, we only focused on the adult life stage, and we modeled it with velocity and depth. And for velocity, we applied a probability distribution, which is the figure there on the left. And for depth, we modeled the probability of occurrence using logistic regression. So we also assigned a critical time period to each species and life stage where appropriate, which relates to their important growth periods. So that's where we want to kind of make sure that the flows are supported so they can carry out their life cycle. And we can also, because they're seasonal, we can also relate those back to the flow metrics. So then we produced flow ranges for every species and all subbasins. And we also applied it under different probability thresholds of low, medium, and high. And then we ended up with this huge big spreadsheet full of numbers, which is a bit hard to kind of see. So I'm going to show you an example at one subbasin in a couple of slides' time. But first of all, we produced suitability maps across the entire study area for the focal species to understand how the flow alteration affects the willow and the chub. So this is an example for willow adult, where the blue subbasins indicate the conditions are suitable and the reds are unsuitable. So here's the example of the flow ranges and hydraulic needs that we can manage towards based on the life history needs of these species. So this example illustrates, this is using dry season base flow metric at the subbasin in Aliso at the treatment plant. So each box represents various flow ranges, so moving left to right. It's under current, then reference, focal species needs, willow and chub, and future conditions. So we can use this information to understand if flows are currently suitable for the species, and then we can lay out potential management options. So in this subbasin, we can see that the flow ranges for willow seedling and adult are supported by current flow conditions. However, for the chub, the flow ranges are too high, so they're kind of way out. So this basically means that the depth is currently too shallow for arroyo chub, and some options for management would be to increase the flow or do some channel rehabilitation. Okay. I think there's some questions that came up in the chat.
Yes, so there is some discussion that was in the chat over the break, and
Okay.
I'll leave that to the document that I'll send around with the chat transcript in it. For this section, Christine Medic was asking about the willow. She says, for the willow, was the distribution of flow across the channel, which will impact the width of the riparian zone considered?
Yeah.
Yeah. Chris responded
Oh.
already, but you're welcome to respond as well. But what Chris had said was, yes, we utilized the current channel morphology and focused on the flow depth in the overbanks and riparian areas.
Oh, yeah, that's pretty much what I would say. I mean, we focused on kind of one cross section and split it into different slices. So the overbanks on the sides were kind of where we would expect the willow to be. So were modeled themselves.
Wonderful. And then Dwight Mudry has commented that he has a comment on slide 54, so the one right before this.
Oh, yes.
Yeah, I find this to be a really interesting slide because it brings everything kind of together.
Yeah.
The various things that you're looking at, plus even management things. So it's very good about that, but it also helps to point out that the arroyo chub is probably a very inappropriate species to have included as a focal species. And the second bullet on the chub, of course, seems to be contrary to everything you've been working on, and to look at how to reduce flows. This one seems to indicate to keep this species, which has never been reported in Aliso Creek, there, you'd have to increase flows. So my comment would be on this, that inclusion of the tidewater goby as a focal species, even though it's been discussed several times as being in a location that is not being studied and that is not being included really in this study, seems to be the most appropriate thing to do, because if you included the tidewater goby, you would find that it would very closely match that black box of the reference flow in at least the lower portion of that black box in the very flows below 1 CFS. And I don't think it can be too late to include something like the tidewater goby, because this species is in Aliso Creek, was there historically, not now, but it was historically there just before urbanization, and urbanization is definitely contributed to its being there, being lost from the entire drainage, actually, the lagoon. So I'm thinking that if you included tidewater goby in this, you would have a species that reflects the actual flow conditions prior to urbanization, and it's like the canary in the gold mine and the coal mine, because everything that's done upstream affects the lagoon at the bottom. The formation of the berm, the inclusion of the lagoon, and the presence of the tidewater goby are all dependent on very low flows at Aliso Creek. I'd also like to point out that this slide really, it says here flow ranges at Aliso at the CTP, it should be, but and people who are working upstream should recognize that this is at the CTP, and upstream you may have entirely dry sections, because during the summer dry periods, the flows were historically very low at the lagoon. I think that's enough said about that. Thank you.
Thank you very much. Yeah, just to note on the goby, the tidewalk goby, when we were discussing the focal species, we did that was discussed. It was brought up, but because, as we've mentioned before, we didn't model specifically the estuaries, so it wasn't included. But and I think Eric kind of put something in the chat a bit earlier that they are being considered under the restoration projects that are going on there. Yeah, they wouldn't be considered in our study. But thank you very much. We do appreciate that that is an important species.
And then we have one question that just came through. Christine Medic is asking, but why arroyo chub?
Good question. I think we had several discussions about which ones to include. I think because the arroyo chub was also co-occurred. I think I can get the slide up here. So it also co-occurred with the stickleback. So that was also the reason why. I think you, I'm not sure if you were actually a part of those discussions. I seem to remember that you were. So we did have extensive discussions in, so there was various reasons why we included.
Yeah. I think the confusion may be that, you know, when we started this project, the study area, right? So for the purposes on the study, we discussed that we needed to pick a set of focal species for the entire study area, knowing that certain species would be more relevant in some parts of the study area than others, right? And as you show in this map, Katie, right? And so the arroyo chub was selected because within the study area as a whole, which is shown on the map you're showing, it was determined to be an important focal species based on, you know, probably historic flow conditions, right? And so even though it may not have been reported in Lower Aliso Creek for the study area as a whole, it was considered one of the key focal species. Again, for Lower Aliso Creek, it may not be the most important target to aim for in terms of flow management, but it's included in the analysis because of consideration of the overall study area.
Yeah, so this slide here is just an example of one of the subbasins, and it is based in Aliso. So as Eric said, it might not be the most informative at that area, but in other, we've done this for every subbasin as well.
Yeah.
And so are you going to choose a different species for Aliso that would be more appropriate? I guess I'm I'm just a little confused about how that's going to translate over, because it's not a representative for this particular watershed. Or are we just going to have the willow and that's the only indicator species that is appropriate for this watershed?
Right,
Yeah. Oh, sorry.
Yeah, go ahead, Katie.
I was just going to say at this point we won't be adding in any more species, but yeah, we can just focus on the willow for this watershed. But we do have the information from the chub as well that can be informative. I don't know if you want to add to that, Eric.
No, I think that's right. We're not adding any additional species at this point. So for this part of the watershed, this part of the study area, we just, in terms of setting management targets, the willow would be the main species, but also, you know, obviously we can look at the CSCI and ASCI data as well, as also informing, you know, how we might manage flows. And then I guess, you know, relative to the goby, right, we do have, as you know very well, Chris, right, we've discussed extensively inflow requirements into the estuary that we want to target. And so we have had extensive discussions about how much flow would be appropriate coming into the estuary under future restored conditions. And so those can also, all of those together, right, can be considerations for managing flow in Lower Aliso. The ability to support the willow, ability to support healthy, you know, general biological communities as indicated by the CSCI, and what we know from the restoration planning of what we'd like to accomplish in terms of inflows into the estuary.
Great. So I'm not seeing any other questions in the meeting chat, and I don't see any raised hands. So I think that we might be good to move on to the future scenarios.
Thanks, everyone.
Thanks, Katie. Okay, so we also evaluated future scenarios of climate change at mid-century at Aliso Creek. Aaron alluded to that earlier, and projected water conservation across all three of the tiers. And so for our future climate scenarios, we considered multiple global climate models, or GCMs. So the figure that you see here represents kind of an ensemble of effects, with the change in temperature on the x-axis and the change in precipitation on the y-axis. And so these red GCMs that we boxed here are the 4 that we selected, that we try to select GCMs that bookend the range of effects. So for example, the CNRMC5, so the top one, is a wetter, cooler scenario. We have the CCSM4 on the mid left. That's more of a scenario with moderate changes in precipitation, but it's on the cooler side. We have MEROC 5 that tends to be on the drier side in terms of precipitation. And then we have the CAN ESM, which is the wetter and hotter scenario. And so for more information on kind of the details of the global climate models and the analysis that we did, Aaron and Rich presented in a lot more detail on the previous slides from the previous SAG meetings. You can find those on the website as well, the county website. And so with this information, we considered the current alteration status and direction, and the future change direction to determine if we think conditions may improve, so in blue, or degrade in red. If the future change was less than 10%, we actually classified that as uncertain. So for example, a subbasin that was likely altered high under current conditions, but in the future declines by 30%, that would be an example of a subbasin that will likely improve. So the flow conditions will go in the direction of improvement. So what you see here are some example maps for the wet season base flow magnitude in terms of the flow needs for ASCII, or the Algal Stream Condition Index. And so we found that for the scenarios that tended to be drier or more moderate changes in rainfall, we tended to see conditions that would actually improve for the ASCI. And then on the right-hand side, you can see conditions that tended to be wetter in the future. We would expect possible degradation for those. And so overall, we found that there are variable results depending on the global climate model and depending on the metric. But as you can see here, there's kind of variable results. It's really just dependent on which scenario we're looking at. And so in summary, given the uncertainty in the future climate projections, we're not providing definitive conclusions or recommendations based on future climate. We will be going into a little deeper discussion on our key findings for the future climate predictions in our annual report, and we'll have all of the data and the maps available for everyone to view and to scroll through in our appendices. So be out in the lookout for those when we post the link. And we do recommend that you continue tracking these changes over time. And so we also considered the impact of water conservation or increased water conservation across all 3 tiers. This is an example of prioritization maps from tier 2 under the current scenario on the left, the map on the left, and then the water conservation scenario on the right. So we can use this information to flag areas where we think priorities may change in the future. So in this example, the number of high priority subbasins decreased from 11 to 7 under the water conservation scenario. And then the number of low priority subbasins actually increased from 25 to 31. So this indicates that there may be some benefits of water conservation to the bugs and algae in certain areas. And so overall, we found that water conservation may reduce the suitability for willow in some subbasins. So in this example, the number of subbasins with unsuitable flow conditions in red increased from 8 to 12 under the water conservation scenario, and the number of subbasins with suitable flow conditions in blue decreased from 34 to 30. So in this example, water conservation may reduce the suitability for willow adult in some areas. And so this is just one example for willow adult. We also looked at all of the other species and life stages. All of our findings are going to be included in the final report as well. And so with that, we can pause for questions and discussion.
Wonderful. So we do have one question that's going back and forth in the chat. Christine Medic was asking, please clarify why algae improve with less water. Is it a decrease in algae considered an improvement in the index? Eric Stein responded saying, good question, Chris. It's not a decrease in algae. It is a decline in the ASCII score, which is an index of the health of the algal community. And Christine had a question about, the definition. What does that mean, health of the algal community? And so Katie says, hi, Chris, the index is based on several component metrics like species richness, percent tolerant species, that all integrate to produce the index. And Eric said, a likely explanation is that this location currently has too much water, so the algal community composition is different than what would be expected under natural conditions. So I think that closes that loop, but Christine, if you have additional questions, or Chris, if you want to add on to that, or if anyone else has questions, you can add them to the chat or raise your hand.
No, okay, that sounds good. I'm gonna move on. So if there's no other questions, so the next part of our presentation is just kind of wrapping up some of our overarching conclusions and, giving you links to where you can ultimately find our results in the data products that we produced. And so circling back to these key questions that were posed in the WQIP special study. So Amanda started out with these key questions. Where can you actually find our results in our data products for each of these? So for the first and the second question about characterizing reference conditions and how that relates to different flow requirements, you can find all of this information in our Shiny app and also our final report. For the third question, which is about identifying data gaps, that is going to be included in our final report. And I think we also touched on this in our annual report from last year. And then for the questions 4 through 7, which are all about relating the biological index score to the hydrologic alteration statuses, you can also find all of this information in our final report. And that's going to include all the data products, all of the raw data, the CSVs, and then also the maps as well. And so I have the 2 links at the bottom. The first one is for the Shiny app, and the second one is for our flow ecology study page. All of the materials from our previous meetings and also from our annual and final reports are going to be posted on the project website below. And so in terms of our overarching conclusions, at least from the hydrology and the prioritization, as Erin mentioned, we found that imported water accounts for about 35% of stream flow on average during the summertime. But this does vary by receiving water, so the different tributaries, and then also the seasons. And then another key finding is that outfall discharges contain about 50% imported water on average. But again, there was wide variability across MS4 outfalls through the study area. We also found that hydrologic alteration affects biological condition to varying degrees. And so what Katie showed was that CSCI and ASCII did show similar patterns in some areas. So some of the areas were flagged as high priority for both CSCI and ASCII. There are other additional areas in terms of ASCII that were flagged for additional consideration in terms of flow management, and those were, some of them were located in Aliso Creek. And then we also found, I just want to note that the flow ecology tools that we developed can be used to prioritize subbasins for flow management. So if you get a chance to explore the Shiny app, you can see that we have different user inputs that you can change, like total number of metrics altered. Oh, sorry, I think someone, HYUR, we can hear you. You can mute yourself. Thanks. So I was saying the Shiny app allows users to kind of change different thresholds of alteration. So how many metrics need to be altered and the percent of time flow needs to be altered for the different metrics. And so you can see how priorities may change with different alteration thresholds. And then overall, we found that about 40% of the subbasins were prioritized for flow management and 60% were prioritized for a separate stressor evaluation. And then lastly, in terms of our conclusions for management, we found that the flow ranges necessary to support focal species can inform flow management actions. However, in some locations, channel rehabilitation combined with flow management may be necessary in certain reaches, especially in areas where the channel morphology is widened or enlarged. Those enlarged stream reaches may not have access to the floodplain, for example, to provide inundation that are necessary to support the willow. In some widened stream reaches, we may not get the depths necessary to support the Aroa chub. And so again, we're going to be flagging some of those areas where we think that channel rehabilitation along with flow management may be used in combination to provide flows that are suitable for multiple different endpoints. We also found that water conservation has the potential to improve conditions for overall stream condition in terms of the CSCI and ASCI. As Eric alluded to, in some of the more urbanized reaches, in Lower Aliso Creek, for example, flows or base flows may be augmented. And so in those areas, when we actually reduce the base flows and increase water conservation, the overall stream condition may improve. However, we did find that water conservation may decrease suitability for willow and Aroa chub under the current channel configuration. And I do want to note that Katie has also identified the depth in the other hydraulic needs like shear stress, velocity that are necessary to support the focal species. And so this is critical information that can be used to inform the design of future restoration, channel restoration projects as well. And then lastly, We found that the direct effect of climate change was highly uncertain, and it really depends on the global climate model that you're looking at. And so with that, we can pause for any questions and discussions on the overarching conclusions.
Wonderful. So we had a little bit of a discussion following the algal discussion we had before about temperature. And let's see, Katie kind of summed it up by, we focus solely on flow for this analysis, but we recommend several subbasins for further evaluation where temperature and other conditions could be a factor. Because Christine Medic even said, you know, it will be a primary factor for algae growth. Josh Westfall followed that up with, I think we need to recognize that this is a prioritization tool. There are a ton of correlative factors, channelization, temperature, nutrients, and Eric replied, good point, Josh. This is a statistical and not a mechanistic analysis. And here's a link to the paper on ASCII that provides more detail on what goes on into the index. And let me see. Okay, I'm going to go back to another question that we got in the middle of that from Roger Buteau asking, are these conclusions going to be formally submitted to the San Diego Regional Water Quality Control Board? And if so, will this lead to it being placed on their agenda? If not on the agenda, does it require XO, potentially human EO, or staff administrative certification? So this kind of goes into what I'll talk about in the next couple slides, but we're going to be including all of this information in the final report as part of our annual report for WQIP compliance. And so very similar to the progress report that we had last year and submitted in technically February 1st of 2021, it'll just be an appendix to our annual report. And that's kind of how we submit it to the San Diego Regional Water Quality Control Board. It won't necessarily be placed on their agenda. It doesn't require any sort of certification by the board. If they do have questions, they might include it in their comments on our annual report that we get yearly. But beyond that, that's kind of my understanding of how we'll be presenting this to the board. And then Christine Medic had a question. She says, originally this study was going to look at how the changes would impact mitigation sites supported by artificially high flows. Will this be included?
Yeah, that's a good question, Chris. So for this study, we actually didn't have the scope to look at specific mitigation sites that are supported by those artificially high flows. But the data that we were producing and the tools that we produce we're hoping that these tools can be used to inform some of those more specific questions, or could lead to additional projects that that can implement and use the findings from this study.
Roger Buteau is asking, how do we get notified at the annual report? So we will be sending a link to it actually in early February 2022 once it's posted on our website. I've kind of created like an email distribution list from all of the SAG and TAG meetings. So if you've ever registered for one of them, if you've got the meeting invite, if you're here today, then you will be sent that email that notifies you that it's available to view via our website. And if you're watching this, not live, you're watching it as a recording and you want more information on that, you can head over to our website. There's a link at the end of the presentation to check if it's there already, if it's past February 2022. But if not, you can just email me and I can get you onto that distribution list. Yes, and Grant, thank you, Grant. He posted our website, the southocwqip.org website that includes all of our South OC Water Quality Improvement Plan, WQIP, annual reports. All right, I'm not seeing any other questions about this section, and I don't see any hand raises. So I'll go ahead and take control because I'll be going over the potential applications of the study. So kind of moving into what we could potentially, how we could potentially apply these flow ecology products. They're listed here as questions. We think that the data can help us answer, help you answer. They're very in line with the questions that we looked at before. So what parts of the WMA would benefit the most from flow reductions or flow augmentation? And because sometimes our data says that maybe more flow would be beneficial. And then if so, how much flow reduction or augmentation should I design for if you are designing for the flow management projects or even channel restoration projects? Another question that these products could potentially help answer is what is the tolerance of flow reductions or augmentations before we see an impact? And where are areas where it makes sense to approach partner agencies for multi-benefit projects? When we're looking at this as a prioritization tool, again, it's just one piece of the prioritization puzzle. So we'll bring this to the table along with other data and information that we have, but it gives us an opportunity to kind of look at where would benefits arise from flow management or restoration projects, and how do we approach partner agencies with that information. And so here's kind of a distilled list of how these products could be used. Area or prioritizing area for low flow diversions, which is one of our flow management strategies, is the first one, and we can do that with current data products as well as developing flow management goals. If we wanted to add some additional work elements to the current data products, we could also, use it to design channel rehabilitation projects by getting some of the design parameters out of this data for different depths and things like that. And then we could also plan for adaptation to future conditions if we wanted to kind of look into that a little bit more. And so here's kind of a flow chart of how we envision these products being used, where, like I said, one piece of the project planning puzzle, we have other data in addition to this. One of the big focus of our Wqip is our outfall studies. And so we have a lot of outfall water quality priorities because of all of the data gap filling and all of the monitoring and assessment that we've done at our outfalls. So with those priorities, those outfall water quality priorities, we can combine them with water resource priorities that we have, that our partner agencies have, and we can look into some candidate flow management products. And when we're looking at those flow management products, we can see where is reduction or augmentation most needed, and that helps prioritize that lower box. And then as we're going into selecting flow management products, we can actually ask ourselves, how much flow can be eliminated at outfalls without impacting downstream biological beneficial uses. If that's what we're going to be doing at this specific outfall, if we're going to be doing a diversion, how much flow before we impact downstream, because we don't want to go too far. And then kind of an offshoot of this, giving existing or reduced flows, what are target channel hydraulics for focal species? And so sometimes that might lead us more so along the stream channel rehabilitation design side of things instead of flow management projects. So that's kind of how we see these study work products working out and being incorporated into our general plans for selecting flow management products. The next slide is a poll again. So if you try to click on the screen, you can see, you can get to that URL, and then I can also post this URL into the chat. And it asks, which of these data product applications are you likely to do? So if you're thinking about it like scale 1 to 5, like if it's a 1, you don't need to check it, but if it's a 4 or 5, like, oh yeah, I might be doing that, go ahead and check that box. And if you have another response, you can click that and type it in there as well. Okay, great. It looks like it's working. I have some responses coming through. Any links will be live for a while, so if you have a chance to fill it out later, that is fine as well. That's great. We're getting more responses coming in. Wonderful. So it seems like it's kind of distributed somewhat evenly. The top two, which are able to be done with the current products, have the most responses. And then the bottom two have a little bit less. And there are some other suggestions there as well. So thank you for filling out the poll. And our next slide, yes, please continue to fill out the poll. I see some other results coming through. And that's great just to get some feedback on how you envision using these product applications. So the next slide is just another pause for questions and discussion regarding the potential applications. I do see a question from Josh Westfall. Is there an estimate of how far downstream these metrics and or work products can be applied? I'm trying to think. Maybe Aaron can speak to this a little bit about how far we anticipate being able to use this data. I think that we had talked about kind of aggregating some of the conclusions at a watershed scale, or at least a sub-watershed scale. But what are your thoughts, Aaron?
Yeah, I think you're totally right, Josh, that we might identify one reach that looks to be augmented by a certain margin, and then you might think, hey, pulling a CFS out of that reach would be beneficial and tolerable. But if you move further downstream, maybe the alteration is not as substantial, and so you can't look at it on a just a one by one segment basis. I think what we're going through right now, the process we're going through, is to kind of distill these up to a little bit higher level when it comes to guiding flow management decisions, and that means separating these watersheds into slightly bigger chunks than what you saw on the map that I presented earlier, and what Chris and Katie have been presenting. More functionally complete sections of the watershed, and making sure that then there's not a misalignment between a sort of approach or a certain tolerance that you might specify in one part of the watershed, and being misaligned with something you might specify somewhere downstream of that. So that's the synthesis part of turning this into into more concrete management guidance. So I don't have a specific answer in terms of downstream, but I would assume that any flow removed from upstream is going to have some effect downstream, and so it's really a matter of making sure any upstream flow recommendations are compatible with everything downstream. And I think Chris said it well. You've got to look all the way down to a point where you may have a different focal species, or you may have a different management target. But that's my take on this as well, Chris.
Are you bringing the Chrismetic? Or
yeah, Chris
okay.
just made a comment. Christine just made a comment that every reduction upstream will need to be evaluated for the entire area downstream. And I would say I agree. It also doesn't mean that anyway, the management approach and the necessary flow could change along the length of the stream. So it's not just a zero-sum game, but yeah, the evaluation through the entire downstream reach is an intent. I think that's how you would intend to use these products.
The only thing I would add to that, Aaron, is if there's a specific project that's being contemplated, then it's likely that project, as part of their evaluation, will do some additional, more detailed modeling, hydrologic modeling, based on what they're contemplating in their project. And so that additional project-specific modeling could then be, the results of that modeling could be fed into the tools that Chris and Katie presented to get some insight into the potential biological implications of that project as the changing flows propagate downstream.
Yeah. Yep. I would also add additional monitoring. You know, if you're in a part of the system where the flow being produced by the model is sort of in that, you know, that very low range where you're not totally sure whether, you know, how much of that is surface and subsurface. I think a project advancing this may have to do some additional, you know, longitudinal monitoring in that segment to sort of better characterize surface flow conditions.
Yep, definitely.
Yeah.
Thank you both. We do have one additional question. Mike Beenan asked, wasn't the $2.5 million Aliso Creek Urban Runoff Recovery, Reuse, and Restoration Project, also known as the Aliso Creek Water Reclamation Facility, designed to remove flows above 1.5 CFS to protect Aliso Beach? I'm not sure of the specifics of how much it was designed for.
It was a higher flow threshold than 1.5 CFS, and I'm disappointed that I can't pull this out of my random access memory. Although
I can make a quick comment.
Dwight wrote the report, so yes, Dwight, why don't you chime in?
Yeah, just a quick report. Yeah, 12 years ago or maybe it was more than that, when the project was designed, the constant flows in the creek were about 10 CFS all through the summer, day and night. So there was about 10 CFS there, and the project, when it was permitted to withdraw water about 1.23 CFS down as long as the flows were above 6 CFS. So when it was permitted, the flows were at about 10, and the permit allowed withdrawals down to 6 CFS, withdrawals of 1.23. So effectively, it could be water could be withdrawn until you got down to 4.77. But 1.23 was the expected withdrawal rate. And of course, now the flows are below 3. So there's an effort by the district to go back to the permitting to see what can be done under current conditions. That's why we have such a great interest in what the urban runoff component is of the creek today.
Wonderful. Thank you, Dwight. So there's another question from Jenny Ta. Curious how this work connects to the California Environmental Flows Framework. Is this being considered a CEFF case study? And if so, are there plans to address Section C of the framework?
Yeah, good question, Jenny. So this study is actually one application or CEFF case study. So CEFF represents the California Environmental Flows Framework. And so we are producing a separate paper that kind of crosswalks some of the work that we've done, especially under the third level that Katie presented on our focal species and how that maps back to the statewide framework. I will say that in terms of the sections of CEFF, we really focused on section A and B, which are based on reference flow conditions, and then also based on the needs of the focal species, or our more specific species models. We do not do anything with section C, which is more about developing balanced environmental flow recommendations that kind of compare the trade-offs between reductions in flow, for example, and benefits to humans or benefits to ecology. So we don't go as far as section C. I can include the link to Ceph for those of you who are unfamiliar with the framework. So you can find, we just finished the draft of the framework, and so you can download it on that website to get a little more context on what we're talking about. I don't know if Eric has anything to add.
Yeah, the only thing I think that's correct. Chris, the only thing I would add is that the analysis that you presented relative to water conservation strategies, it could be one component of something that was considered under Section C, because it does start to look at sort of the implications of water, decisions on water use that are made for sort of non-ecological purposes, right? And so, so that could be a component that goes into Section C. But the other thing that I would say is, Section C is intended to be applied at sort of the project specific or sort of sub-basin or sub-regional scale. And so I think that where we would get into Section C, which is, as Chris said, really about trade-offs between how you manage flow for ecology versus how you manage flow for other demands, that would be probably done under the context of specific projects. So as hopefully people begin to use these tools to consider and evaluate specific projects, whether they be flow diversions or stream rehabilitation projects or things along those lines, that's where we would envision getting deeper into that Section C analysis to analyze the trade-offs between different proposals being contemplated.
Great, thank you both so much. So yes, Chris put that link into the chat. I'm not seeing any other chats for questions at this point. I know we do have one question from before that I wanted to circle back from Christian Romberger, but I'm gonna finish off the last two slides really quick before circling back to that. So this slide kind of gives more information, or where you can get more information. And again, these are clickable links, but I will add these links to the chat now. So we have a study website that goes over all of the past SAG and TAG workshops. You can click into those links and it will take you to where the agenda was posted, the PowerPoint was posted. If there's a recording of that, you can access the recording there as well. And you'll see the information about this meeting is up there right now as well. And then if you go into the progress report link here to the right, you'll see the one that we did that posted February of 2021. And that's a progress report up until that point. Again, our final report will be posted with the annual report for fiscal year 2021 in February of 2022. And you'll see the link for that again on our study website. And we'll be emailing things out to kind of prompt you to go check out that final report. A kind of a schedule, I've went over this a little already, but the progress report again finished January 2021. Final stakeholder meeting is today, and then the final report will be by the end of January 2022. And the final report will include the Shiny app that Chris showed today, and we'll have results from the level 1, 2, and 3 analysis. And yeah, everything will be posted to the regional clearinghouse that we have. So that's the end of the slides that we have. We have some extra slides, but I do want to make sure that we circle back now that I know we have time. Aaron, for slide 18, this question is referencing. This is Christian Romberger from CDFW. He says that it's unclear if those are the actual calibration results or are they only an example, and what residual information could you share with us?
Let me head back to that slide, Christian. Taking the slow route back, but forgive me.
It's a good review of what we've all
review in reverse.
Yeah.
Oh, you said slide 18. And the question was, are these the actual calibration results
Yes,
Or-
it's unclear if these are the actual calibration results or are they only an example, and what residuals information could you share with us?
Yes, these are a view of real calibration results, but they are only a subset of the overall calibration effort that we went through to determine the validity of the model. There are a report on the calibration results with a lot more metrics present in that January 2021 progress report that Amanda just went through. And I think short of bringing that up, I'd have to refer you there. Or there's also a fairly decent summary of a lot greater number of calibration results in our November 2020 presentation. So yeah, I would say that we looked at root mean square residual. We looked at Nash-Sutcliffe efficiency. We looked at percent bias. We split up percent bias across different flow bins to kind of make sure we weren't having an overall non-biased condition, but having bias in certain flow ranges or excessive bias in those ranges. We also compared, as I mentioned, the different pathways for water against what we were seeing in terms of the isotopic composition split. So yeah, there's a lot more calibration metrics presented in that report. And there will be calibration statistics presented for the Trabuco Creek gauge in the final report that gets published in January this year. It's a non-answer. I'm sorry, Christian, but I don't. Yeah.
And just generally, would it be safe to say that there were no kind of outliers that you guys were able to locate, generally speaking, in terms of the way the calibration came out?
It was safe to say that when we calibrated for one area and then we applied that calibration to another part of the watershed, we ended up with results that were within range. Okay. And so nothing really surprised us too much. We did have to apply some different loss coefficients to the Trabuco system than we did to like the Aliso system. And I think that's, in my opinion, accountable to the fact that there is more groundwater interaction there, potential for deep groundwater loss. There are some extractions from the riparian area in that system that are not accounted for in our model that do have an influence. And so that was the area where we probably had to dial the parameters, the most different from the other parts of the watershed in order to get a reasonable match on the lower flow range. But I think it's explainable based on the difference in geology between the Trabuco system and the Aliso and some of the other coastal systems, which have really limited alluvial aquifers. So, yeah.
Yeah, it doesn't seem unreasonable from this side, but I'll have to take a look at the final when it comes out and see what I think. But I appreciate it. Thank you.
Yeah, sure thing.
Wonderful. And thank you to everyone who contributed questions or comments this meeting. This whole SAG tag process has been wonderful. And I'll open it up again if anyone has any final questions or comments before we sign off. But that was the end of our presentation. I realized I never introduced myself. I was thinking about it afterwards, but I'm Amanda Abrahamian. I work with the County of Orange. We have a great study team here. We have Eric Stein. I didn't introduce him either. He works with Wqip as well, alongside Chris and Katie. And so, yeah, thank you for being here. If you have any questions, again, you can contact us on our website. And there's a contact us button on there, and we'll get the email if you email us through there. But also, I'm sure you've had many emails from me, so go ahead and just press reply on any of those as well. All right, I think that's the end of our presentation. Thank you all so much for being here. I appreciate it. And please look forward to a meeting recap email that I will send out once the recording and the meeting materials are ready for distribution. So thank you all.